Hello, good morning, good afternoon, good night, wherever you might reside. Today, here at Topple, we will be presenting on DAML Bifrost demo. My name is Brad Sennett. I am the Technical Operations Manager here at Topple, and who will be presenting is Edmundo, the blockchain engineer here at Topple. So, Edmundo, the floor is yours.
Hello, good morning, or good afternoon, good night to everyone. So I'll be presenting today on the integration that we did with DAML and with the Bifrost node at Topple. So I have Nick here that will be also joining us. Maybe I should add him to stream. Here we go. Hello, Nick. Hello. So Nick is there. Well, I let him introduce himself.
Hey. For anybody that doesn't know me, I'm Nick Edmonds, head developer ecosystem over at Topple. Been here with Topple for about 5.5, almost 6 years. Been here since pretty much the beginning, building the blockchain, and now switching over as of this year to be able to show off all the cool stuff that we've been building.
Great, Nick. So today we are presenting this DAML integration. So let's start maybe with what is DAML. So DAML is the digital asset management or markup language. So it's a domain-specific language that you can use to model real-life contracts. For example, when you rent an Airbnb, you sign a contract with your host. You are the guest and he is the host. And you go to the Airbnb website and you have a kind of contract with him where he has to provide accommodations for your trip. And in exchange, you have to pay him. And you have certain rights, and he also, or she has also certain rights. For example, if after the end of my stay, I broke something and the owner can exercise her right or his right to ask for a compensation for the damage I caused. And he would be, or she would be exercising a right on the contract. And if I don't get the accommodations I expected, I can also exercise my right to request a refund. And that's the kind of contracts that we can model in DAML. So real life contracts, there are people or parties, that's the way they are called, that interact, and they can create new contracts, have them signed, and have the choices of the given contracts exercised. So that in our example of the Airbnb, the contract is the contract with Airbnb, with the guest and the host, and the choices are to request refund, request money to repair something. So using this kind of contracts, we can implement several stuff. And interestingly, we can connect them, for example, to a blockchain like the Topple blockchain, or as we call it here, the Bifrost node. And when we connect, we can do some things like we can have contracts that describe our interaction with the blockchain. And here I'll be giving a small example of a demo. So the demo will be a very small poll that we will be asking the user to vote on something. And maybe let me share my a small presentation here. So this will be what we will be doing, the process that we will be sharing. We have two parties here. We have Alice and we have a robot, but we will call it the operator. The operator is a party in the DAML system that can also create contracts and exercise choices. And the party Alice is a person which will or who will also create contracts and exercise the right. So here what we will have is that the operator will give a ballot to Alice, and Alice will vote on a question. So the question is a very simple question in the software. It's just, is this software a demo? And what Alice will do is Alice will send that ballot to a ballot box, yes, if she thinks it's a demo, and a ballot box, no, is if she thinks it's not a demo. And this will be backed by the blockchain. That means that this operator will be minting a token, a vote token, that will be transferred to Alice, and Alice will, on time, create a transaction to transfer that voting token to one of the addresses that we want to where we want to vote. So there will be one address that is designed to be where we are going to vote. All the yes votes will go, and there will be another address where all the no votes will go. So after Alice votes, we will get the vote transferred to this address, and then at the end we just want to count the addresses. So we have the yes ballot box and the no ballot box, and we count the tokens in yes and the tokens in no, and that's our small process system. So this will be the app we will be demoing right now. So let's start with that. I will share my screen to show you the actual application.
Real quick before we move on. So just to clarify for everybody out there, you brought up when we're talking about the contracts that they are connecting to the Topple blockchain, and then also that the votes are tokens. Could you elaborate a little bit on what you mean when a contract is connecting to the chain, and then also where the tokens actually exist?
Yes, maybe I can show you with how it actually happens. So I have some slides for this. I will go to the beginning. So we have our different parties here. We have Alice, we have the operator, and we have the broker. The broker, so Alice is the person who is going to vote. The operator, as we said earlier, is the machine who is representing like a system that will do some stuff. Yes, it's just a software, and the software will be acting as the operator. And then we have the broker, and the broker is another piece of software that will intercept some of the contracts that are happening in the DAML server. And when it sees those contracts, it will be doing something on the Topple blockchain. For example, mint an asset. Then after the asset is minted, the asset will be transferred, for example, to Alice's wallet. And then the broker will continue to listen. So there will be things that are happening in the contract world and things that will be happening in the Bifrost world, so in the blockchain world. And the translator between these two worlds is the broker. So just a very small example. At the beginning, Alice will create a connection request contract. And the operator will see that contract and will exercise its choice to accept that connection. So, and when the operator accepts that choice, in the contract, we specify what will happen. And these arrows here represent what will happen. And what will happen here is that we will create an asset minting request, and that's a new contract, and we will also create an accepted connection contract. And now here is where the broker sees this asset minting request, will go do some stuff on the blockchain, and then will once again create a new signed asset minting after the asset was minted on the blockchain and transferred where the contract specified. This will be created here. So this is more or less what will happen throughout the demonstration. Is that clear? Any other questions?
Yeah, so put in my own words. So the contracts are deployed and exist off chain. So they're existing on a separate server from the actual Topple nodes and blockchain, and then it's sending requests back and forth to the chain to update the state when it creates transactions. And the tokens that are being created for the votes are actual tokens on chain that are also represented in the smart contract. And so, and I know you're going to show it in the demo, but I just wanted to point out that's a really nice feature and part of the reason we chose DAML in the first place, because we have the same verifiability and provability through the transaction setup and the signing routine to sign transactions through DAML and have that sent on chain and create tokens through the smart contracts, while having all the business logic and data in the smart contract layer and the computation existing off chain. So it's really good from a scalability aspect and really good from a composability aspect too. Yeah.
Yes, exactly as you said it. And another advantage here is that when we are using the DAML contracts, since it's a domain-specific language, and it has a very particular semantics reflecting the real-world contracts, you can program at a very high level. So you can you just create an asset minting request, and you don't have to worry about how to send that, how to serialize, how to sign. It will just be handled by the broker and then will be given back to you. So that's another thing. So now let's move to the demo. So here I will share my screen. And now, so here we are. This is the demo application. Let me introduce the different parts here. As you can see, I have installed the Ribbon plugin. Your file. What happened here? For very strange reasons. Let me try this again. Oh, just, well, this is weird, but we'll figure this out. So once again, it seems like the Ribbon wallet is not being found. I'm not sure exactly why. Let's try to reinstall it here. Extensions. I will disable it and enable it just to check if maybe that will fix it. No, then remove, and I can hopefully load it from here. It's here, downloads. So well, this was not expected. It was working a few minutes ago. But anyways, just let me find it. Ribbon.
Always a fun part about live demos.
Yes, yes, exactly that. That
Never fails.
you never expect it to happen, and somehow it's not as you expected. Ribbon. Just be web. Here it is. I found it. So let's try to reinstall the ribbon. It's here under downloads. So this, yes, select. Okay, there we go. Oof, there it is. So let's continue with the demo. Something weird happened, but we are still online. So this is our demo. I will connect just to make you a tour of the wallet. So we connect. We have a blockchain turning. So this time we are using a private network. This wallet will turn on a private network. On this private network, I have no funds, I have no policy, I have nothing on my wallet. So I will log in and see what happens. So the first thing is, let's see what happens here. I have already set up this to have some parties here. I have created the operator party, and I have also created the Alice party. So let's connect here. This is the simple login where we will connect, and we see this dialog that appears, and it asks to connect. So this is the first part, that where the website tells us or asks us if we want to Ribbon to authorize this web app to perform operations with Ribbon. So here we tell, okay, I trust the local host and confirm. And this starts the creation of the different contracts. So if we look here, we see in Ribbon, then we still have 0 police, and we are waiting for the funds to arrive. After a while, we should get some tokens that will arrive here. We've got our vote token. So this is the token that we will use to vote, but we still have 0 police. So, and now the screen has changed. So we can see here, once again, we have 1,000 police and we have a token to vote. And we can see that the application has detected the Ribbon plugin and asked the plugin after the authorization. I can ask if I am authorized. I can, for example, ask for the address of the address, so of the wallet. So here, thank you for connecting. I have sent you 1,000 police, and now this is the final question. And yes or no, this is a demo, yes or no, I will say yes and submit. So what will happen here is that my wallet, so the application will request, will create a transaction first, and that transaction, since that vote token will be going out from my wallet, that I need to authorize that. So what will happen here is that the application will go create the transaction, prepare it for me, and then tell the Ribbon app, I have this transaction, please sign it, and I will send it to the node so that this vote token can arrive to the destination you voted. So it can be sent either to the yes or to the no. So here we have, as we see, 1,000 and vote, and we click submit. And then it tells us, please proceed to the transaction. After a while, we will get here, we get a message to review the transaction that we are signing, since here, basically, it's asking us to send some money from, or police, or an asset, or whatever, from our wallet. So here it tells us that we are sending a other asset, which is the vote token, and the transaction fee is 100 polis, and well, these 900 polis are being sent to my same address, so they will end up in the same place. And if you want, you can really check the transaction here. This is what was provided. So what we do here is confirm, and when we confirm, we can start waiting for the results. So what will happen here is, once again, if we check our wallet, we see let's see, we see that the token is there no more. So we have sent that token, and that we are 100 polis less rich than before. So, and we can also see the result. The result here is that we got a Topple testnet demo NFT, and well, the NFT part is not yet implemented, but here we can see the results of the demo. So we have 100 and 0% because we only have one vote. So what we can do here is, for example, reconnect and see what happens. If I reconnect as Alice, well, first it tells me that there is a reauthorization that has to happen. So I reauthorize the application, and then after a while, it will see that the contract exists on the network, so it will just give me the result. So if I click on reset demo, it will just remove this contract that says that I have already voted and will allow me to start again. So that would be the first part of the demo. Maybe, Nick, do you have some questions? Or yes, so there are some comments here, some questions. What's this? Can you see the tuple object in the DOM through the console? Yes, so the question comes from James, and it says, can you see the tuple object in the DOM through the console? And the answer is yes. So we can open a console here. I'm not sure how to make this bigger. No. No, this is making another thing bigger, not what I want. So, but here, if I can show you the console here, maybe, hopefully, if I write tuple, I get the tuple object, and here I can see it on the console. So it shows me, I'm not sure if you can see that, but you should be able to see that the tuple option has 4 functions: enable, is enabled, sign transaction, authorize, get balance. So yes, we can, that's the object. That object is injected in the DOM by the ribbon plugin. So yes, that's the answer. We can also do execute some commands from here, but now the application is handling all of that for us, so we are not touching anything. Okay, so another question. Maybe Nick, do you have some comment?
Yeah, basically just so are you about to show like repeating the process and like generating more tokens?
Yes, I can also. Let's, for example, connect as another user. Now, the thing is, when I connect, for example, as Bob, I'm using the same wallet here. So it will, let's see, it will once again ask for a confirmation. This was done to speed up the demo and to make sure it, in theory, that should be done only once. So now we can see once again that we have some funds. We are waiting for the funds to arrive. We got another vote token, and if we check Now you will see that we have 1,900 polys. So it has given us even more polys. So once again, we can vote no this time and submit. And it will ask for the transaction to be signed. So in theory, Bob should have another wallet. So this is why we are having the same user acting as two different parties, but using the same wallet. That's why we get this. We will accumulate a lot of polys. So when I confirm here, we wait once again for the results, and you will see the in a moment the results of this. Yes, now we have 50-50. So that means that there has been one vote for here and another vote for here. All of these computations are done through DAML. So, and maybe something that I can show you that is also here is, this is the actual, this is what the broker is doing. So the broker, if you look at this, is contacting the node and sending the transactions to the Bifrost node and handling all of that, and then sending back contracts, the exercise of different contracts to the node to the DAML node. So we have here all of the work, integration work between the two worlds is being done by the broker, which is running on this terminal. So here we have another demo. What I can do also, another interesting thing, and I hope I won't break this, but basically I can create a new wallet. A new wallet here. What I can do is, if I remember well, there should be settings, and then I can delete the wallet. And yes, I will delete. We are entering risky territory here. Yes, I want to delete. And when we have deleted the wallet, it will ask us to create a new one. So we get started, we create a wallet. Let's go. I understand. We go through the process of creating a new wallet here. I understand. Just let me get something to write down what I will get. And this is my order. So just let me write this down or download. Okay. I have it here. Yes, there it is. And now I can continue. It will ask me to check word 9, 1, 2, 3. 9, 11, 15, 14. I'm hopefully copying the right words. A new wallet password, total 1, 2, 3, 4. I shouldn't say that, but this is a demo, and this will be deleted and forgotten after this. So now we have created a new wallet. I have saved my password and I understand and everything is correct. Done. Now we have a new wallet. Hopefully it is there. And this new wallet has 0 polys and no token. So we can once again reset the demo and reconnect. And this new wallet will get a new token. Once again, a new token and 1,000 polys. Once again, no, this will fail. This will fail. And the reason this will fail is because I was using the wrong network. It was configured for the Valhalla network, and behind the scenes, we will have a scary message telling us that chain network mismatch. Okay, so that's what happened here. We can just kill this and imagine nothing happened. Let's try that. If it lets me. So. Now we will relaunch the broker. So this will create an anomaly here in the demo because there are some contracts that are there that shouldn't be there, that should have been consumed. This is a demo. This is not in production state. So these kind of cases are not yet. So the broker is up again. So this has failed, and let's do this again, and hopefully this will work. Just double check that we are on the right network. Yes, we are. And we can confirm, and now it works. So yes, now I can reset the demo and revoke and reauthorize. And this time, let's hope we get the right polys. So we are waiting for the funds to arrive. This new wallet has 0 polys. And if everything goes well, now we have 1 vote and 0 polys still. It takes a while. One of the tricks here is that we cannot send the two at the same time, because it won't, the transactions request generated will collide. So we need to send the one after the other. So now we have 1,000 polys and 1 vote. This is a completely new wallet. So we can vote again and submit. And now we will get once again the result. We need to sign it here, confirm. And after a while, we will get the result of this operation. So this time we have 3 votes, and 3 are for no, and 2 are for no, and 1 is for yes. So that explains the result there. And all of these computations are done in DAML. So most of the logic here is done in DAML and not in the UI part, the React part.
Yeah. So how is it calculating this number? How is it finding the number of tokens for yes and no?
For yes. So maybe, yeah, I can show it to you. I can show you the contract here. That will be the easiest way. So this is the actual contract. Now, here is the demo poll show results contract. And in this contract, you see that there is a capture result. So there is, I will show a detailed explanation of how this works, but basically it captures the response contract. And then it computes the total votes, which is the balance in the yes address plus the balance is in the no address. And then it just that's the percentage. The yes divided by the total votes multiplied by 100, and the no's divided by a total votes. And it creates a demo process results. And this is what the UI is listening for. So when this contract appears, it shows the UI. So now I can show you the whole process. So continuing from the slides, this one, there we go. So we had here the asset minting, that the broker gave us the asset minting, and there is the accepted connection contract. So the operator, or maybe if you want, it might be easier if we go from the beginning just to see what happens at the beginning. At the very beginning, once the authorization has happened at the tuple and at the ribbon level, Alice creates a contract in the node telling I want to request a connection. And the operator will see this contract. In DAML, we say that the operator is an observer. So we add the operator as a parameter, and the operator will see this contract and then will exercise the connection request accept. And once it accepts it, the contract states what needs to happen. So what needs to happen here is that we need to create the asset minting request and the accepted connection. And the accepted connection is to tell the robots, the operator something, and the minting request is to tell the broker something. So the broker will see this asset minting request and intercept that and do its magic on the Bifrost node, on the blockchain. And then after it's done, it will exercise some choices on that contract and then will return the signed asset minting that tells us that the transaction is confirmed. And once the transaction is confirmed, this operator will take this accepted connection and exercise the start poll. This will automatically send the police to the user. So the 1,000 police will be sent when the connection is accepted by the operator. And we'll also create the demo poll. So the demo poll is where the user can vote. So there are two choices in the demo poll. I can exercise the choice to vote yes and the choice to vote no. And depending, basically, in both cases, we create an asset transfer request, but in one, we transfer the asset to the yes address, and in the other case, we transfer it to the no address. And we also create a demo poll voted contract that, once again, is meant for the operator to intercept. So this asset transfer request will be once again seen by the broker and processed. And basically the processing here is it will just create a transaction for us and then give us an unsigned asset transfer request. And with this, this is an unsigned transaction. The operator will capture this. It will exercise the demo poll voted capture signed request. And when doing this, it will create the demo poll signed request. Just recall here that Alice, or the user, never talks directly to the Bifrost node. We are always talking to the DAML node. That means that we are always trying to look for contracts and exercise the choices. So here we need to transform that unsigned transfer request that comes as a contract from the DAML tuple library and transform it to something that Alice, or the application developer, knows better, which would be this demo poll sign request. And then Alice, when Alice sees this demo poll sign request, it will execute something on the UI, something that will call the ribbon node and the ribbon application, and the ribbon application will provide the signature. And having that signature, we can have that signature back and pass it to the demo poll sign request sign. So this is another choice in this contract. And this will once again trigger the execution of the unsigned asset transfer request and the unsigned asset transfer sign choice in this contract. And will create the demo poll complete. Once again, all this demo poll complete, we like Alice has the choices that she exercises, and then we create like a contract for the operator to manage the flow of the application, and we create other contracts for the broker to interact with the Bifrost node, with the outside service that is the Bifrost node. And the broker, both will answer to us using another contract. So we are basically creating an archiving, that's the technical word is archive a contract. So when the contract is not used anymore, it becomes archived and inactive. So here we have the demo poll completed. So when the demo poll is completed, the operator once again sees that and it will ask for balance. Once again, we create an asset balance request that will be seen by the broker and a demo poll show results that will be seen by the operator. The asset balance request is seen, captured, and then we get an asset balance response, which will be captured by another choice here. And when we capture the results, we finally create the demo poll process results that we have just seen. And that's captured by Alice. And Alice will see this contract, and in the UI, we will just poll the UI until the DAML server until it sees that this contract is available. And when the contract is available, it will process, it will show the results of the poll. That would be it. So, do you have maybe other questions, Nick?
Yeah. So when it is going through smart contracts, first one, I guess, is you said archived is when you're finished with a smart contract. So is archived the same thing as deleting a smart contract?
Deleting would be that it doesn't exist anymore. So, but in DAML, as far as I understand, they don't erase, they just archive, and the contracts are there to be seen, but in an inactive mode. According to their documentation, they are GPRS, the European protection data protection law compliant. So they have some pruning functions that allow you to prune the ledger, and my guess is that that would remove the archived contracts because you have the right to be forgotten in Europe.
That's actually a really good point.
Mm-hmm.
Yeah, because the structure of the smart contracts are set up as UTXOs, right? So it follows the same process of you initiate a transaction to like create a smart contract or to consume a choice on a smart contract.
Mm-hmm.
And what it's actually doing is the smart contracts themselves are immutable. So it's just creating a new updated version of it and replacing the old one with that new version. So it fits in line with our token UTXO model. But that is a nice thing in that you do have that pruning option and the ability to always show that the output existed at some point. The other thing I want to bring up was to reiterate, the tokens that are being created are all native tokens that exist on chain. And then you're storing a representation of those tokens, like basically the output. Once it's confirmed on chain, you're storing the output as a processed result in the smart contract, right?
Yes, I'm storing
like the vote, yeah, one way or the other.
What I'm storing. In fact, in the smart contract world, I'm not storing anything, just the results, processed results. Because what I do is I could in theory also model that as a set of smart contracts, and each vote goes to a different contract, a yes and no. But here I'm completely using the blockchain as a storage for the votes. So the votes are minted on the blockchain, and then they are transferred to some address on the blockchain. And what the smart contracts are doing, they are just polling or asking the broker to give the balance of a given address. They are not actually storing the actual information of the tokens. Everything here about this vote is stored on the blockchain.
Which is actually really, I think, a powerful tool for us in that that means all of the on-chain state can still be an accurate representation for off-chain computation smart contracts. So you can actually have robust smart contracts that rely on on-chain data and are able to manipulate that on-chain data without having to duplicate that data off-chain.
Mm-hmm. Yes, it's true. There is no duplication here.
Yeah, and so because I don't think you haven't talked about the trigger yet, which is performing the action.
Trigger.
Yeah.
Yes. Yes. Mm-hmm. Maybe I should explain the trigger, the notion of trigger. So here, when we look at this, this image, we have the three parties: the operator, Alice, and the broker. So the broker is a Java application. So it's constantly listening to the contracts, to a stream, so a reactive stream that comes from the node. But the broker is generic. So the main idea behind the broker is that you can write your application in DAML and don't have to write Java code to implement the logic of your application. Here, if you want to have like the maximum development speed, you would just use React and DAML. So the problem is that when you communicate with the broker, for example, I do an asset minting request. So the broker gives me some assigned asset minting request with status confirmed. So when I get that, that's not normally part of my application logic. So that belongs to blockchain world. And I need to capture that in one of the contracts that my application uses. In my case, for example, I have the polls. So I need to transform the blockchain, the stuff that happens in the blockchain world to contracts in my polling application. So I need to have some poll contract that reflects that. And that's where triggers come handy. So the idea behind triggers is that you write DAML code that is also constantly not querying, you would say, but it's some sort of listening to what happens in the DAML node. And you write in DAML in the same language, which is very Haskell lookalike. So you write your code there to exercise. And for example, this allows me to get a sign minting request confirmed and transform into a poll completed object, which reflects what is happening in my domain logic. So the triggers are that. Maybe the best way is to show you a trigger, or because there is only, for this application, there is only one big trigger. I will remove this and present screen 2. Okay, so this is VS Code, and there is auto ops here, and this is the triggers file. So the triggers file just has a big function that returns a trigger. So this is Haskell notation for function that returns a trigger. And here we have what happens here. So what happens here is, for example, I query or maybe I'll do the easiest part here. So in the first part here, maybe the right name here, set connection, just to make it clear. But here what I have is that I have a query, a trigger query. T-query means that I'm having the trigger data type that will look for this connection request. So Alice will create a connection request, and it will give me like two things here: the connections, the data, and the contract. The contract helps me to extract to exercise something. So what I'm using here is the actual FST means the first element of a tuple, and SND the second element of a tuple. So the first element of this means just to get all the contract IDs, which I will use to exercise the connection request. So what this trigger does, this one, is the following. It looks for connection requests. This is not useful. And then this map A will go through the tuples. For each one, it works like a map, basically, and it will dedup exercise. That means dedup means the deduplication, because the problem here is that there can be some scenarios where we see a contract and we exercise, and we can sometimes exercise twice the same thing. So DAML comes with an operation that says, if you see by any chance an operation that looks the same and it's being executed on the same thing at the same time and with the same parameters, please don't consider the two of them or the three of them, just one. So dedup exercise tells this map to get the contract for the connection request and execute and exercise the connection request accept. And this is basically where I code the logic for the operator to see all the connection requests and accept them. That's it. And I do the same with accepted connection. When I see an accepted connection, I will first look for the sign asset minting. I will just check that the status is confirmed. So I want to start the poll only if the transaction that's minted is confirmed. That means that it's on the blockchain at a certain depth. And then I will exercise the accepted connection start poll. And basically all of the triggers are like that. And what DAML provides us is an utility that I tell run this file using this function as a trigger, and it will basically run an application that will constantly look for the changes in the DAML ledger and execute the different operations that I ask it to. So basically transforming my integration logic, bringing it back to my domain logic.
I just want to point out that this is like a really big deal when it comes to smart contracts, because automation is one of the thorns in the side of smart contract languages and development right now. Is typically when you want to interact with smart contracts, it requires manual input or some sort of botting behavior to run transactions and push them to a smart contract. This is fantastic from the sense of you can set up a trigger and have it listening and running in the background. And I do want to point out that the way to view triggers in DAML is it is correcting behavior on the ledger view of DAML versus like firing off an event if this happens. It's less, if this then that, and more so, I guess that kind of like declarative view of this state is incorrect, change it to this state instead.
Mm-hmm.
That makes sense.
Yes, yes, exactly as you say it. And here is an example. Here, like the sign asset minting doesn't mean anything to my application, and I want to put that correctly. So what that means is that I can start my poll. So I exercise the contract that starts the poll, the choice. So I'm putting things right. And if we go looking at the accepted connection start poll, you will see that that contract immediately archives the this is the accepted connection start poll. What it does, it takes the signed asset minting, and it archives it. Then sends the poll list and then starts the poll, and that would be it.
Very
So
nice.
that, yes.
Yeah, this is yeah, I mean, I think ending on the trigger part is actually like a really great kind of stopping point, because that's really one of the unique features of DAML that is not found in any other smart contract language, as far as I know. And being able to deploy this alongside your smart contracts is really great from the perspective of anybody that would like to automate any behavior in their smart contracts um, to react to events happening inside of their smart contracts, and have that happen directly in DAML and in the smart contract purview, rather than something that exists entirely off chain, entirely outside the smart contract platform, something that you'd have to build and integrate yourself and test. This is all internal to the DAML platform. Um, and I think that's one of the strengths of being able to move computation off chain um, is this event only has to happen once, and all the checks are in place to verify that that event happened without having to replicate that event across, a distributed network. Um, you can run it once. You can generate the computational output. You can sign, verify, commit that computational output inside the smart contract, um, and then assure everybody else that needs that information that this actually happened. Um, and sync up any other nodes that need to update their smart contract set. Um, but also the tokens that are generated on chain only exist through valid transactions generated this way. So it's kind of almost a two-stage process of generating transactions on chain and through the smart contract. So you kind of have a two-stage checking mechanism here. But yeah.
Yes.
But thank you very much for this, Edmundo. Did you have anything else to say?
No.
Cool.
No.
All right. Well, I guess yeah. Thanks y'all for showing up today. Thank you for watching this demo. This is really exciting stuff. I'm hoping we'll be able to show off more of this in the short future. We have some really cool ideas coming up with this. Yeah, thanks y'all.
Thank you.